Example 5, we are solving for theta. We want to find theta values that are between 0 and 360, but not including 0 or 360 because of the parentheses on them. Again, we've got an equation here where we've got two different trig functions, and it's not really possible to solve for theta if it's in two different trig functions. So you want to find a way to condense that down to one trig function. If you look at your trig identities, we do have an identity that looks like this. Tangent of 1/2 x equals sine x over 1 plus cosine x. And that pretty much matches up with what we have here. So we can transform this equation into just tangent of 1/2 theta. So that's how we're going to start the problem. We're going to make that tangent 1/2 theta. Then I want to get theta by itself, so we're going to do inverse tangent to the other side. And once you do inverse, it's now time to look up where does tangent equal 1. So tangent equals 1 at, here we've got 45 degrees. And tangent is 1 at 225 degrees. We add 360 in to make it a general solution. That way we can get multiple answers. Now, we want theta, we don't want 1/2 theta, so now we gotta get rid of the 1/2 and multiply everything by 2 in both equations. So that's 90 plus 720n. Here we get 450 plus 720n. And then we want to look for our answers that are between 0 and 360. So right away I see 90 is an answer, because 90 is between 0 and 360. If I were to subtract 720 from this, it would be too small. So I can't get an answer there. If I add 720 to 90, it'll be too big. So 90 is my only answer from that equation. Here, 450, if I leave it alone, it's already too big. If I subtract 720, it would be negative, so I'm not going to get anything from this equation. 90 is the only answer that we get for example 5.